Good day everyone, my name is Rebanting Flores and welcome back to my YouTube channel. For today's video, let us discuss about tabular integration. And the objectives of this video is that at the end of this video, the learners are now able to integrate problems using tabular integration and compare tabular integration from integration by parts. But before we proceed, let us first discuss and define what is tabular integration. Tabular integration defined as a method of quickly integrating by parts many times in sequence. This method requires one of the functions in f of x and g of x be differentiable until it is 0. So, tabular integration is closely related to integration by parts, yet in tabular integration, it uses table as the main base of solving for the antiderivative of the given functions. So without further ado, let's apply and make a comparison between the two, tabular integration and integration by parts, through these given examples here. So first example is to evaluate the integrals of x squared e raised to the power of x dx. So as you observe, this given is already solved in my video about integration by parts, yet I have already also included this given equation, given problems here for us to make a comparison between the two way of integration. So as you observe in the tabular integration, it is said here that it includes f of x and g of x as the main base of evaluating through tabular integration. So we should find where in this given as is f of x and g of x. So in this given, we have f of x as x squared and g of x as e raised to the power of x. So, and by that, we are now able to make a table for based from the given. Our f of x is x squared and our g of x is e raised to the power of x. If we are going to solve the derivative of x squared, it will be 2x. And the derivative of 2x is 2. And the derivative of 2 is, since it is constant, it will be equal to 0. On the other hand, our g of x, since it is not differentiable, it will still remain. So e raised to the power of x, e raised to the power of x, e raised to the power of x, and so on. And if we're going to connect the two, our f of x and g of x respectively, we are going to find the antiderivative of the function given here through like this. So we came up with x squared ex e raised to the power of x minus 2x e raised to the power of x plus 2 e raised to the power of x plus c as the value of our given here integrals of x squared e raised to the power of x dx. So just copy and note for us to make a comparison in the next slide. So this is the given example from the previous videos about integration by parts. So as you observe, the value here, or the antiderivative we came up here is x squared e raised to the power of x minus 2x e raised to the power of x plus 2 e raised to the power of x plus c is similar to our tabular integration as the comparison. So they provide the same answer. Next is to evaluate the integrals of x cubed sine x dx. Since it is tabular integration, we should find the f of x and the g of x. F of x here is the x cubed rather, and the g of x here is the sine x. And by that, we are now able to make a table. So our f of x is x cubed. The derivative of x cubed is 3x squared. The derivative of 3x squared is 6x. And the derivative of 6x is 6. And the derivative of 6, since it is constant, it will be equal to 0. On the other hand, we have the g of x here, the sine x. The derivative of sine x is negative cosine x. The derivative of negative cosine x is sine x, negative sine x. And the derivative of negative sine x is cosine x, and the derivative of cosine x is sine x. So it looks like there's nothing changed in the g of x and the f of x, so it becomes 0 as we differentiate the terms x cubed. So, and by that we are now able to find the value, which is negative x cubed cosine x plus 3x squared sine x plus 6x cosine x minus 6 sine x plus c. Again, just please copy and note for us to make a comparison in the next slide of this video. So, if we evaluate this given using integration by parts, the process will be look like this. Our u is x cubed, our du is 3x squared dx. Our dv is sine x dx, our v is negative cosine x. The formula of integration by parts, or the LBP formula, is the integration of u du, again, the integration of u dv is equal to uv minus the integration of v du. Just substitute the given to our given formula. We came up with x cubed quantity of negative cosine x minus the integral of negative cosine x quantity of 3x squared dx. Next is we just exclude the constant and combine the first term. So we came up with negative x cubed cosine x minus 1 multiplied to negative 3 integral of cosine x quantity of x squared dx. Next is negative x cubed cosine x plus 3 the integral of x squared cosine x dx. Next is just set aside muna the first term and we will continue the second term. So we have 3 quantity of x squared sine x minus the integral of sine x quantity of 2x dx. Next is the integral of 3 quantity of x squared sine x minus 2 the integral of sine x dx, and then proceed with minus x cubed cosine x plus 3 integral of x squared cosine x dx. Again, set aside and then copy 3 quantity of sine squared sine x minus 2 sine integral of sine x dx, and then 3 sine again 3 quantity of x cubed sine x minus 2 integral of x quantity of sine x dx, and then next is 3 quantity of sine x quantity of sine x minus 2 quantity of x quantity of negative cosine x minus the integral of negative cosine x dx, and then 3 quantity of sine x squared quantity of sine x minus 2 quantity of x quantity of negative cosine x plus sine x. Next is the 3 quantity of x squared sine x plus 2x cosine x minus 2 sine x. Just distribute the 3, so we came up with negative 3x cosine x plus 3x squared sine x plus 6x cosine x minus 6 cosine x plus c, which is very similar to our tabular integration a while ago. And that will be all for today's video. Please click the notification bell for you to be updated in my next video. I just want to give credit to our instructor, Sir Mateo Canida, for I have used the LM material or learning materials in our school as my basis or reference in making of this video. Thank you and God bless.